Look up at the night sky. What do you see? You might see the moon, a few planets, and countless stars. Each star is a tiny point of light in the vast darkness. They seem so still, so permanent. But this stillness is an illusion. The universe is a dynamic, ever-changing place. It is full of life and death on a scale we can barely imagine. Every single star you see has a story. It has a beginning, a middle, and an end, just like we do. The question is, where do these brilliant celestial bodies come from? Imagine the biggest, emptiest room you can think of. Now imagine that room is filled with just a few specks of dust and a faint wisp of smoke. On a cosmic scale, that is what a nebula is like. These are not solid objects. They are incredibly vast clouds of gas and dust spread out over immense distances. Some are so large that they stretch for hundreds of light years across space. To put that into perspective, a single light year is nearly 6 trillion miles. These nebulae are the universe's reservoirs of raw material. They are the cosmic dust bunnies floating between the stars, waiting for something to happen. The gas in these nebulae is mostly hydrogen, the simplest and most abundant element in the universe. There is also a bit of helium and trace amounts of other heavier elements. The dust is made of tiny grains of carbon and silicon, like microscopic bits of soot and sand. Our exploration starts now. We are about to dive headfirst into one of these magnificent star-forming regions. Forget thinking of space as an empty vacuum. Instead, picture a celestial ocean filled with invisible currents and tides. In this ocean, the nebulae are like giant, slow-moving whirlpools. They are places where the fabric of the cosmos is churning. Gravity is the engine driving this motion. It is a force that is weak over small distances but unstoppable over cosmic scales. It patiently tugs on every single atom and dust grain within the nebula, pulling them ever so slightly closer to each other. This process is incredibly slow, taking millions of years to show any noticeable effect. Imagine floating through the silent, endless ocean of space between the stars. It might seem like a vast, empty void, a realm of pure blackness. But this emptiness is an illusion. Scattered throughout our galaxy and others are breathtaking clouds of gas and dust known as nebulae. The word nebula comes from the Latin word for cloud, mist, or fog, and that is precisely what they are. These are not earthly clouds of water vapor, but immense interstellar clouds composed primarily of hydrogen, helium, and tiny particles of cosmic dust. They are the building blocks of the cosmos, colossal reservoirs of raw material waiting for the spark of creation to ignite them. These celestial objects are truly staggering in their scale, dwarfing anything we can comprehend on Earth. A typical nebula can stretch for dozens or even hundreds of light years across. Our journey now takes us deep inside one of these immense dark nebulae. Imagine we are floating within this cold, silent cloud. The space around us is not completely empty, but filled with a thin fog of hydrogen atoms and tiny specks of dust. It is incredibly cold here, just a few degrees above absolute zero, the coldest temperature possible. In this profound chill, the atoms and molecules move very slowly, like they are in a deep cosmic slumber. For millions of years, the cloud might simply drift through space, a serene and seemingly unchanging entity. But even here, in the quietest corners of the galaxy, a powerful and relentless force is at work. Gravity. Gravity is the universal architect. We have now reached a truly transformative moment in our cosmic journey. Deep within the dark, collapsing clumps of gas and dust, a new object is beginning to take shape. The relentless pull of gravity has squeezed the material at the center of the clump into an increasingly dense and compact sphere. As the pressure mounts, the temperature soars. The core, once just a few degrees above absolute zero, now heats up to thousands of degrees. While this is not yet hot enough for nuclear fusion, it is hot enough for the object to begin emitting its own light. This glowing celestial embryo, shrouded in its dusty cocoon, is known as a protostar. The birth of a protostar marks a fundamental shift in the process. The object is no longer just a passive clump of gas being acted upon by gravity. As the protostar grows, the material falling towards it does not simply crash straight onto its surface. Due to the initial slight rotation of the parent cloud, the infalling gas and dust carry some angular momentum. Think of an ice skater pulling in their arms to spin faster. As the material gets closer to the protostar, it spins faster and faster, eventually flattening out into a wide rotating structure around the protostar's equator. This structure is called a protoplanetary disk or accretion disk. It is a vast, spinning platter of gas and dust, many times larger than our own solar system, that continuously feeds material onto the growing protostar at its center. This disk is an incredibly important and exciting part of the story. It is not just a feeding mechanism for the protostar, it is also the birthplace of future planets. Within this swirling disk of cosmic material, tiny dust grains begin to stick together. The birth of a nuclear furnace, this is the moment of ignition. As the core temperature climbs past the critical threshold of about 10 million degrees Celsius, the impossible begins to happen. The protons are moving with such ferocious speed that their kinetic energy finally overcomes their mutual electrical repulsion. When they collide now, they do not just bounce off each other. They get close enough for a new, more powerful force of nature to take over, the strong nuclear force. They fuse together, initiating a chain reaction that will change everything. This is the birth of nuclear fusion. In this process, known as the proton-proton chain, hydrogen nuclei, protons, are fused together in a series of steps to form helium nuclei. It is a form of cosmic alchemy. The star is taking the simplest element in the universe and transforming it into the second simplest. The ignition of the nuclear furnace in the star's core sets off a final crucial adjustment. The star now has two opposing forces locked in a titanic struggle. Gravity continues its relentless mission, trying to pull all the star's matter inward and crush it into a single point. But now it faces a worthy adversary. The tremendous outward pressure generated by the nuclear fusion in the core pushes back against gravity's crush. For a short while, the star might pulsate slightly as these two forces battle for supremacy. But soon, they settle into a state of perfect balance. The outward push of the nuclear reactions becomes exactly equal to the inward pull of gravity. This state is known as hydrostatic equilibrium, and it is the hallmark of a healthy, stable star. The star stops contracting. Its size, temperature, and brightness stabilize. It has found its comfortable, long-term state of existence. It is no longer a changing, evolving protostar, but a mature star that has reached its final form. It has officially been born. The birth of the star has a profound impact on its local environment. The powerful radiation and stellar winds that now stream from its surface begin to blow away the last remnants of the nebula that gave it life. For the first time, the star and its potential new family of planets are revealed to the open galaxy. If the star was born within a cluster, it now joins its siblings, a glittering family of newborn stars lighting up the once dark cloud. The pillars of creation in the Eagle Nebula are a perfect example of this, where the dark columns of gas are being eroded and illuminated by the brilliant young stars that have recently formed within them. Our star is now a fully fledged member of the galactic community. It has a specific identity defined by its mass, temperature, and brightness. It will spend the next long phase of its life in a state of quiet stability, a reliable beacon in the cosmic darkness. It has completed its incredible journey from a diffuse wisp of gas in a cold, dark cloud to a brilliant, self-sustaining nuclear furnace. Of all the stellar nurseries in our corner of the galaxy, none is more famous or more spectacular than the Great Orion Nebula. Located about 1,350 light-years away, it's actually the closest massive star-forming region to Earth. This proximity means that it's bright enough to be seen with the naked eye, appearing as a fuzzy, indistinct star in the middle of Orion's sword. But, when you look through a telescope, it resolves into this breathtaking celestial cloud, a vibrant tapestry of glowing gas and shimmering starlight. It's not just a nebula, it's a bustling metropolis of starbirth, a place where we can actually witness the entire process unfolding in real time. At the heart of the Orion Nebula lies a very young star cluster known as the Trapezium. This small group of 4 massive, brilliant stars is the engine that powers the entire nebula. They're cosmic newborns, less than 1 million years old, and they blaze with an incredible intensity. Their powerful ultraviolet radiation streams out into the surrounding cloud, heating the hydrogen gas and causing it to glow with those beautiful pink and reddish hues that you see in images of the nebula. Within the larger expanse of the Eagle Nebula, some 7,000 light-years from Earth, lies one of the most iconic and awe-inspiring structures ever photographed, the Pillars of Creation. First made famous by the Hubble Space Telescope back in 1995, these are 3 colossal towers of interstellar gas and dust. They're truly monumental in scale, with the tallest pillar stretching for over 4 light-years from its base to its tip. They look like immense ghostly fingers reaching up from a cosmic abyss, silhouetted against the bright glow of a young star cluster located just outside the frame. These pillars are a dramatic snapshot of a star nursery being sculpted by its own children. But, these magnificent structures are not permanent. They're transient features, actively being destroyed by the very stars they've helped to create. The massive, hot young stars of the nearby cluster NGC 6611 are unleashing a torrent of ultraviolet radiation and powerful stellar winds. This onslaught is eroding the less dense parts of the nebula, a process called photoevaporation. While the Orion Nebula and the Pillars of Creation are among the most famous, our galaxy and the universe beyond are filled with a stunning diversity of stellar cradles. Each one has its own unique character and tells a different part of the cosmic story. Take the Carina Nebula, for example. Located about 7,500 light-years away in the southern sky, it is a colossal star-forming region, even larger and more active than the Orion Nebula. It is home to some of the most massive and luminous stars known in our galaxy, including the volatile and brilliant star Eta Carinae. Another fascinating example is the Tarantula Nebula. This is not even in our galaxy. It resides in the Large Magellanic Cloud, a small satellite galaxy that orbits the Milky Way. The Tarantula Nebula is the most active star-forming region in our entire local group of galaxies. Our cosmic journey is now drawing to a close. We have traveled across vast distances of space and time, from the cold, dark heart of an interstellar cloud to the brilliant, fiery birth of a new star. We began with simple ingredients, a diffuse fog of hydrogen gas and tiny specks of cosmic dust, the leftovers from a previous generation of stars. We watched as the patient, relentless force of gravity began its work, gently pulling this raw material together. It is a process of immense scale and almost unimaginable slowness, a testament to the power of persistence in the universe. The journey from a simple cloud to a radiant star is the universe's greatest act of transformation. This grand cycle from dust to light and back to dust again is the engine that drives the evolution of the universe. The stars born today are forged from the ashes of stars that lived and died long ago. It is an unending story of death and rebirth, of recycling and renewal. The universe is not a static museum of ancient objects. It is a living, breathing entity, constantly reinventing itself through the birth and death of its stars. This magnificent story of starbirth is not something distant and abstract. It is intimately connected to our own existence. Every atom in your body, apart from the very oldest hydrogen, was created inside the fiery heart of a star. The carbon that forms the basis of all life on Earth, the oxygen we breathe, the calcium in our bones, and the iron in our blood were all forged in the nuclear furnaces of massive stars that lived and died billions of years before our sun was even born. When these ancient stars exploded as supernovae, they scattered these precious, life-giving elements across the galaxy. This stellar ash mixed with the gas and dust of interstellar clouds, enriching them with the chemical complexity needed for life. One such enriched cloud, about 4.6 billion years ago, began to collapse under its own gravity. It formed a protostar, our sun, and a protoplanetary disk around it. From that very disk, the Earth and the other planets of our solar system were built. So when you look up at the night sky, you are not just looking at distant points of light. You are looking at your own cosmic family tree. You are seeing the stellar ancestors and siblings of our own sun. The light that travels across light years to reach your eyes is a physical link, a connection that ties you directly to the rest of the cosmos. Our journey has shown us that the universe is a place of endless beginnings. Right now, as you read these words, new stars are being born in hundreds of billions of galaxies across the observable universe. In nebulae like Orion and Carina, gravity is patiently at work, sculpting the next generation of suns. The process of creation is not something that happened once, long ago. It is happening all around us, all the time. The cosmos is perpetually renewing itself, filling the darkness with new light and new possibilities. This continuous cycle of starbirth ensures that the universe will remain a vibrant and dynamic place for an incredibly long time to come. We are living in a universe that is still young and full of creative energy. Looking up at the sky is therefore an act of looking into a realm of infinite potential. It is a reminder that even from the simplest ingredients, the universe can create objects of breathtaking beauty and complexity. It is a story that fills us with wonder and encourages us to keep exploring, to keep asking questions. The more we learn about how stars are born, the more we learn about the fundamental nature of the universe and our place within its grand unfolding narrative. So let our journey end where it began, with a sense of awe. The night sky is not just a collection of static lights, but a gallery of creation in progress. They are the lighthouses of the cosmos, and their story is our story. The universe has filled itself with light, and in doing so, it has created the conditions for us to be here to witness it. And as long as we continue to look up and wonder, our own journey of discovery, just like the universe's journey of creation, will never truly end.